Okay, let's talk about code security. And the first threat that I want to talk about with code security is unintended access. Now we're getting into the code. All right. Whether it be GitHub or Azure repos or anything else, you do want to use team-based access for each repo. And in the authorization, you can add individual people in GitHub. And so the recommendation is don't do that. Create teams and authorize the team to the repositories, because what ends up happening is there are a lot of Git repositories that a particular development team needs access to. And especially with the popularity of smaller and more segmented architectures, whether they be, whether you intentionally call it microservices or whether you've weathered the storm of the going too far on the pendulum swing towards microservices and have started to come back already. Either way, it is a definite trend across our industry that larger and larger code bases are being broken up into smaller code bases. And so when you do that, you have multiple Git repositories and you need to give the development team access to each one. And so create a team and then share or give access to the team to each repository. That way, when a team member leaves the organization, removing them from the team automatically removes their access from the code in all of the different Git repositories. Also, make sure you do have enterprise class logins that support two-factor authentication for your code repositories. And then even if a person is still with your organization, if they're not active in the code anymore, go ahead and remove them from that team. And so don't name your teams as people who are part of the organization. Name your teams for what they do. And that way, when somebody changes what they're responsible for doing, well, then that maps with removing them from the team. All right, the next threat is malware injection. We've seen that just in the last year with the huge UA-parser.js hack in NPM. And now NuGet is just as susceptible to it, but it just happens to be that NPM has been in the news a couple times over the last few years, where a seemingly small library that started out with just one committer, somebody that just threw up an open source project, and then some other libraries took a dependency on it. And then those other libraries became really, really popular. And now, because they became really popular, you've got so many applications that now have a transitive dependency on this one little library developed by one person. And then that one person either has a compromised account or something happens, and the account responsible for publishing new versions of that library to NPM gets compromised. Some code is inserted and put in there, and then over time, as libraries get updated, this hack is now running in tons and tons of applications. And just knowing that I've published some NuGet libraries, and it's the same thing with that. If you don't have some good governance on the NuGet account with two-factor authentication and good password and monitoring it, then it's very possible to happen. And it's happened twice now in a high-profile way with package managers, because the default tooling is encouraging us to constantly update these libraries, just like our smartphones are constantly encouraging us to update all these apps. Oh, the app worked fine, but there's a new version. Oh, I guess. And then the phone doesn't even ask anymore. It just updates. Okay. And then we have malware injection. So for that threat, first of all, you want to talk about that with the team, because if you haven't had our conversations about that, then you're not going to have good awareness. But you want to insist on pull requests for every change. Don't commit directly to master. Insist on pull requests, feature branches, pull requests, because then you can see the changes to your CS proj file, and you can see that a new version of a particular package was coming through. And if that particular feature didn't require that new version to come through, then you can question it. And if you are intentionally upgrading libraries, that's great. Let's go down the chain of everything that we're updating and make sure that it's as we expected. All right. Another mitigation is to package the applications with their dependencies rather than link the dependencies at deploy time or even at build time. Now, the default build cadence is to do a .NET restore and then .NET build, or a NuGet restore and then compile. That saves a little disk space in your Git repository, but it leaves the source of the packages at NuGet. And there's an argument in the industry still about whether we should check in all of the libraries in our own applications Git repository, or whether we should get them from NuGet every time. Now, Microsoft has made the decision that for their purposes, they're going to make the default be get it from NuGet every time. But if you do check in the packages to your local Git repository, it does close that attack vector. Okay. So when we're talking about threats and techniques to mitigate the threat, that is a technique to mitigate that threat. The next is static code analysis. When it comes to uaparser.js or any of the others, all of the libraries and all of the current code for the open source libraries can be scanned. And there are really, really good static code analysis tools out there. SonarQube is one of them, and you can read up about their security features at their website, sonarcube.org/features/security. All right, so those are some specific things in your code. And from a process perspective, I mentioned doing pull requests. This is what that process looks like for a build process and pull request. So before I get into the pull request process, we have our private build and we have our CI build, continuous integration build. They kind of do the same things. They just run on a different environment. The private build runs on a programmer's workstation, and the CI build runs on a team shared server, whether it's Azure Pipelines or GitHub Actions. And just like a higher order test in test-driven development, we know that the pattern is arrange, act, assert. So we do some things to get ready to do an act, and then we do some assertions. The act, the big act is compile the code, move from text source code to bytecode. And then the asserts are unit tests and integration tests. And then upon success there on the integration build, we do our static code analysis, which in some teams, as you get more mature about that, you can move that over to the assert column where you fail the build if you don't have if you have any static code analysis warnings. But then after that, we publish the test results, we package it up as a named and numbered release candidate, and then we publish it out to Azure Artifacts. So for pull request, that process is as follows. And this process is a defect removal process in general. But when we're thinking about security flaws or security breaches, we think about that as a defect, okay? And even if it hasn't happened yet, if we can reason through and say that, we are unreasonably vulnerable to a particular threat, well, we can classify that as a defect and make sure that it gets fixed. But you can see the pull request process goes all the way through the CI build from the engineer workstation, and then to our first deployed environment so that we can run full system acceptance tests. And then once that happens, then the team member is able to create a pull request because there is a beta level build or non-releasable build that is packaged up and deployed to our automated test environment. I tend to call it the TDD environment to invoke test-driven development. And we enable builds and deployments on every branch, not just the master branch. And so then we create the pull request, have another team member look at it with a checklist. Okay. Heart surgeons and airline pilots use checklists before they do their jobs. Actually, the more complex and the more professional a job is, the more likely it is to have a standardized checklist. And software surely is sophisticated. And especially when you're thinking about security, the stakes are high. You want the checklist. Okay. So create a checklist for what the criteria by which you are going to accept the pull request, and make sure that it checks the box. And the person who's approving that pull request is basically staking their reputation on the fact that they verified that all those checklist items were verified, and they click the button to merge and complete the pull request.